Okay, so this is the second video for this series. These are the 3 problems that were done in the first video. Okay, and so just to recap, you solve inequalities the same way that you solve equations. There is one exception, which we're going to see in just one second. When you graph the solutions to inequalities and you have just simply a greater than symbol, meaning just a greater than, or a less than symbol, which looks like this, you're going to have an open circle because the solution must be either greater than that number or less than that number. Okay, so it can't be equal to that number, so you don't have a closed circle there, you have an open circle. Okay, so we're going to look at these 2 problems here, but instead of it just being a less than symbol, we are going to make that symbol that looks like this. Okay, so if I have 3x minus 4 is less than or equal to 5, okay, this is less than or equal to, we can solve this equation or inequality as we normally would. Okay, we're simply going to add 4 to both sides, and then we would have that 3x is less than or equal to 9. And if we then divide both sides by 3, we get that x is less than or equal to 3. So when we graph this, we've got 0, 1, 2, 3, 4. And down here we've got -1, -2, -3. And if I graph this, I'm going to have a closed circle at 3 because it can actually be a solution. It would make this statement true. And then everything to the left would be shaded in. Okay, so this would just be shaded, everything to the left. And I can prove this. If I let's pick a -2, and let's show that this works with -2. If I want to check my solution, I can say 3 times -2 minus 4, and is that less than or equal to 5? Well, 3 times -2 is -6. So is -6 minus 4 less than or equal to 5? Well, -6 minus 4 is -10, and -10 is indeed less than 5, so that's true. So this would be a true graph. And if I substituted a 3 in here for x, I would have 3 times 3. So if I want to check that, 3 times 3 minus 4, is that less than or equal to 5? Well, 3 times 3 is 9, and 9 minus 4 is 5, and 5 is equal to 5. So because I have that or equal to part down here, this would also be a true statement. Okay. Now this problem here, we've got 2 times 2x plus 4 is greater than or equal to 12. Now I can solve this one of 2 ways. I can either divide both sides by 2 to begin with. I can divide both sides by 2 to begin with, and I'm left with 2x plus 4 is greater than or equal to 6, and then solve, subtract 4 from both sides. I would get 2x is greater than or equal to 2, divide both sides by 2, and I get x is greater than or equal to 1. Or I could, let me just rewrite this, I could solve this a different way. Okay, I could start by distributing this 2. So I have 2 times 2x, which is going to be, let me zoom in so my handwriting gets to be a little better. I don't know what I did. Sorry about that, guys. Okay, so my handwriting will be better now that I've zoomed in a little bit. 2 times 2x plus 2 times 4, and that's greater than or equal to 12. So 2 times 2x is 4x plus 2 times 4, which is 8, and that's greater than or equal to 12. So I would subtract 8 from each side. So I have 4x is greater than or equal to 4, and then divide both sides by 4, and I still get that x is greater than or equal to 1. So see, I solved this in a different way, but I got the exact same answer because what I did was mathematically correct. Okay, so now if I want to graph that solution of x is greater than or equal to 1, I would start by plotting my points in my number line, and then because I have this or equal to symbol right here, I'm going to have a closed circle at 1, and my arrow is pointing to the right, so I am going to shade everything to the right. So x is greater than or equal to 1. Well, 1 is equal to 1, so that works. And 2 is greater than 1, so that works. And 3 is greater than 1, so that works as well. Okay, but if I wanted to really check this, I would just simply substitute these into the original problem. Okay, so let's look at this next page. Here we go. So now we're going to get into something that's a little bit different. Okay, let me zoom out. Okay, so now is where we're going to end up with this one exception. Okay, if we have negative 2x is greater than 4. When you multiply or divide by a negative number, your inequality symbol changes direction. Okay, so this is the one exception. This is where you have the one thing that changes. It's not exactly the same as solving an equation. Okay, so when you are multiplying or dividing by a negative number, the inequality symbol is going to change direction. So negative 2x is greater than 4. If I divide both sides here by negative 2, I have that x, now because I divided by a negative, this symbol is going to reverse. It's not going to come straight down, it's going to reverse. So I have, when I divide both sides by negative 2, 4 divided by negative 2 is negative 2. Okay, so I have the x is less than or equal to, x is less than negative 2. Okay, so if I plot this, I've got 0, negative 1, negative 2, and negative 3. And out to the right of 0, I have my positive integers. Okay, so I'm going to use an open circle at 2, and everything to the left, because my arrow is pointing left, and I'm saying that x is less than negative 2, so it's got to be smaller, and smaller numbers are to the left. Okay, so everything to the left is shaded. Now I can check my work. Let's use this integer here, negative 3, to check and see if this works. Well, negative 2 times negative 3, is that greater than 4? Well, negative 2 times negative 3 is positive 6, and positive 6 is greater than 4, so that's going to check out. Okay, so we reverse the symbols when we divide or multiply by a negative number. Okay, what about this problem here? Negative 3 times x is greater than negative 9. Well, I'm going to divide both sides by negative 3. And when I divide by that negative, my inequality symbol is going to change directions. So negative 3 times x divided by negative 3 is simply x. And negative 9 divided by negative 3 is a positive 3. So I have 0, 1, 2, 3, 4. We can just add another little number in there. And because this is just a less than symbol, it's going to be an open circle. and then everything to the left is going to be shaded. Okay, so x is less than 3. And again, I can check my work by choosing one of these shaded integers down here. So if I pick a -2 here, well, -3 times -2, is that greater than -9? Well, -3 times -2 is +6, and any positive number will always be greater than a negative number, so I know that that works. Okay, let's look at this last problem here. I've got -2 times x plus 3 minus 5 is less than -3. Okay, my first step here is going to be to try to isolate these terms. Okay, because if this was an equation, if it looked like this, I would say your first step is to move this -5. So your first step here is also to move that -5. Okay, so we would add 5 to both sides. And if we add 5 to both sides, we have -2 times x plus 3 is less than +2. Okay, now you can either distribute that -2 or simply go ahead and divide. So I would divide both sides by -2, but remember when we divide by a negative number, this symbol here has to change. It's got to reverse. So the -2's are going to cancel, and I'm left with x plus 3 is greater than -1. So now I'm going to subtract 3 from each side, and I have that x is greater than -4. So my solution would be that x is greater than -4. So I'm going to plot this. I'm going to have an open circle at -4, and everything to the right is going to be shaded. All my numbers larger than -4, and my larger numbers are always on the right side. Okay, and that's how you would solve and graph inequalities.